Hello guys, today we are studying acceleration. Okay, now see here, a particle is moving in a straight line. Okay, suppose that particle is initially at point A. That means that object is at rest position. Okay, when at time t is equal to 0. Okay, then that velocity or the initial velocity of that particle is u. Okay, this particle is moving in this direction. Okay, and reaches at point B. Okay, okay, in time t is equal to t. Okay, so then the v be the final velocity, v be the final velocity of that particle. Okay, now we know what is meant by acceleration. The rate of change of rate of change of velocity, rate of change of velocity with respect to time, with respect to time is known as acceleration. Okay, therefore the formula for acceleration is equal to change in velocity, divided by time, change in velocity divided by time. Now observe this figure. Let u be the initial velocity, okay, and v be the final velocity, okay. U be the initial velocity at time t is equal to 0 and v be the final velocity at time t is equal to t. Okay, now we know that the formula for acceleration, okay, the formula for acceleration is change in velocity divided by time. Okay, now acceleration is denoted by a. Okay, now acceleration is equal to change in velocity divided by time. That means final minus initial divided by time. Suppose we consider this one is the t1, this one is the t2. So we can write t2 minus t1. Okay, that means acceleration is equal to change in velocity divided by time. Now the unit of this acceleration is meter per second square. This is the unit of acceleration. Okay, now we know that uniform acceleration or uniform motion, when we see that uniform, that motion is uniform. Okay, now see here, a particle is at point A. It covers 5 km distance in 10 minutes. It covers 5 km distance in 10 minutes. That means it reaches at point B. Okay. Again, for next 10 minutes, this particle again cover 5 km distance. That means time interval is same and the distance covered by that particle or that object is also same. Okay. For next 10 minutes, that particle also covers a distance 5 kilometers. So that in equal interval of time, of time, okay, that object covers in equal interval of time, object covers equal distance, okay, then that motion is known as uniform motion. That means that object covers equal distance in equal time interval, so that motion is known as uniform motion. Now, what is meant by non-uniform motion? What is meant by non-uniform motion? Suppose we take same example. A particle is moving in straight line, okay, which is starting from point A. This object or that particle covers 5 kilometer distance in 10 minutes and reaches at point B. Okay. Again, this particle covers 10 kilometer distance in 10 minutes. 10 kilometer distance in 10 minutes. For next 10 minutes, this particle covers 4 kilometer distance. Okay. Now, see here, the time interval is same. But the distance covered by that particle or that object is different. So that motion is known as non-uniform motion. Okay, that means in equal interval of time, object covers unequal distance. Such motion is known as non-uniform motion. Okay. Now, next point, that is equation of motion for uniform acceleration. This point is most important because on these equations of motion some numericals are asked in our regular question paper and also in JEE and NEET. Okay. Now, see here, it is so easy. A particle is moving in a straight line. Okay. A particle is moving in a straight line. Okay. Under a constant acceleration or a uniform acceleration. Okay. So let u be the initial velocity. Let u be the initial velocity. Okay. At time t is equal to 0. Let u be the initial velocity of that particle at time t is equal to 0 and v be the final velocity of that particle at time t is equal to t. At time t is equal to t. Okay. So the particle is moving under uniform acceleration, okay. Now see, let u be the initial velocity. Okay. V be the final velocity. Of that particle. Okay. Let t be the time interval. Okay. A be the uniform acceleration. Okay. And S be the displacement. In time t. Okay. Just observe the diagram. The particle is moving in a straight line under a constant or uniform acceleration. Okay. Let u be the initial velocity of that particle. Okay. That object is at A. Position A. That means that object is at rest. Okay. So at position A, the initial velocity of that particle is u when at time t is equal to 0. Okay. Now this particle is moving under uniform acceleration. It covers a small displacement s in time t and reaches at point B. Okay. When that particle reaches at point B, then v be the final velocity of that particle. Okay. So we know that according to definition of acceleration, or using the definition of acceleration. Okay. So definition of acceleration is change in velocity upon time. So we get acceleration A is equal to change in velocity means final minus initial. So we get A is equal to v minus u upon t. Okay. So v minus u is equal to at. Therefore v is equal to u plus at. Calling it equation number 1. So this is the first kinematic equation, or the equation of motion. This is the first kinematic equation. Okay. By using this equation, we will solve the numericals. Okay. Now see here. Next, after this we will find the average velocity. Average means mean. So mean can be defined by the sum of all quantities divided by total number of quantities. So average velocity, that means u plus v divided by 2. Okay. But we know that the formula for average velocity is equal to displacement equal to average velocity into time. Okay, so the average velocity, which is also find. Okay, average velocity which is also find. Now see here, displacement s is equal to average velocity. This, suppose this is indicated by v bar, so v bar into t. Okay, now substituting this value of v bar in this equation, so we get v bar means u plus v upon 2 into t. Okay, now substituting the value of v from equation 1, so from equation 1, so we get, now see here, from equation 1, s is equal to u plus v. V means u plus 80 divided by 2 into t. Okay, now see here, u plus u, which is equal to 2u plus half at into t. So we get 2 to get cancelled. So ut plus half a t square, that means s is equal to ut plus half a t square, calling as equation number 2. Okay, this is the equation number 2. Okay, so this equation number 2 also known as second kinematic equation. Okay, so we get, now see here, from equation 1, so v is equal to u plus 80. Okay, now squaring on both sides, so we get squaring on both sides, so we get v square is equal to u plus 80 bracket square. So u plus 80 means a plus b bracket square. A plus b bracket square is equal to a square plus 2ab plus b square. So we get u square plus 2u into 80 plus a t square. Okay, squaring on both sides, or suppose we directly write a square into t square. Okay, a square into t square. So we can take from these two u square as it is, 2 get common, so 2a, so remaining here ut plus, here is not 2 is absent, so 1 by 2 into a can take common, so a into t square. Okay, now see here, I adjust here 2 because I want to convert this equation in this form. Okay, so ut plus half at square, that means s, that is displacement. So from equation 2 we can write v square is equal to u square plus 2as. So this is equation number 3. Okay, this equation is the third kinematic equation. Okay, now see, I can revise again. A particle is moving under a uniform acceleration. Okay, so that object is at rest at point A. Okay, so that object is at rest means time period is also 0. So at position A, the initial velocity of that particle is u. Okay, it covers a displacement s in time interval t. Okay, then its final velocity be v. Okay, so u is the initial velocity, v is the final velocity, t is the time period, a is the uniform acceleration, and s is the displacement in time. Okay, now see, according to the definition of acceleration, so acceleration is equal to change in velocity upon time. Okay, so change in velocity, that means final minus initial, so acceleration is equal to v minus u upon t. Okay, so we solving this, so we get v is equal to u plus at. This is the first kinematic equation. Okay, then we find the average velocity or mean velocity. So we know that in mathematical terms, mean or average can be calculated by using the sum of all quantities divided by total number of quantities. Okay, so according to this concept, we find the average velocity. So average velocity is equal to u plus v divided by 2. Okay, but we know that the formula for average velocity, so the average velocity is equal to displacement upon time. So therefore displacement is equal to average velocity into time. Okay, therefore s is equal to v bar into t. So substituting the value of average velocity, so we get s is equal to ut plus half a t square. This is the second kinematic equation. Okay, now from equation 1, v is equal to u plus at, squaring on both sides. So we using the identity a plus b bracket square, which is equal to a square plus b square plus 2ab. Okay, and we adjust that 2. Okay, so because of to convert that equation in the form of s. Okay, so we get the third equation, that is v square is equal to u square plus 2as. Okay, now the next point from this equation, that is displacement in a particular set. Okay, now see here, a particle is moving in a straight line with initial velocity u. Okay, it covers a displacement s in time t is equal to t. Okay, it covers a displacement s in time t, and it also covers a displacement s dash in time t is equal to t minus 1. Okay, t minus 1. Now see here, to find the displacement in time t. Okay, so displacement, so now see here, s is the displacement, u is the initial velocity, t is the time, a is the acceleration. Okay, so displacement means equation number second, for time t is equal to t, so we get s is equal to ut plus half a t square. Okay, this is the displacement in time t. Okay, now so displacement, now the displacement in time t minus 1. Okay, so we can replace this t by t minus 1, so we get s dash. S dash is the displacement which is covered in time t is equal to t minus 1, so s dash is equal to u into t minus 1 plus half into t minus 1 bracket square. Okay. Now we want to find the displacement in t second. Now we want to find the displacement in t second. T second means at a particular second. Suppose this is displacement in 10 seconds. This is displacement in 9 seconds. Okay. Now we want to find the displacement in exact that time period. Okay. So the displacement at a particular time t can be calculated by s1 is equal to s minus s dash. Okay. So now substituting the values. Okay. So we get ut plus half a t square minus s dash. S dash means u into t minus 1. Okay. Plus half a into t minus 1. Okay. Bracket square. So solving this equation, we get the value that is u plus half a into 2t minus 1. 2t minus 1. This is the displacement at a particular time. Okay. So st. So this is the fourth kinematic equation. Or we will find the displacement at that particular time. Okay. Okay. On the basis of that kinematic equation, we will solve one example. A particle is moving in a straight line under a constant acceleration. Constant means uniform acceleration. Okay. It travels 15 meter in 3rd second and 31 meter in 7th second. Okay. Find the initial velocity and constant acceleration. That means displacement is given in a particular time. Okay. So we know that the displacement in the particular time. So displacement, we know that the equation for the displacement in a particular time, okay, that is st is equal to u plus half a into 2t minus 1. This is the general formula. Okay. Now see here that particle moves 15 meter in 3rd second. Okay. That particle moves 15 meter in 3rd second. So now see here for that 3rd second, displacement s1 is equal to how much? 15 meter. Okay. So now substituting this value in this equation. Okay. So we get for 3rd second, that means s3 is equal to u, initial velocity of that particle. Okay. Not given, so u plus half a, acceleration also not given, into 2 into t, time period is 3 minus 1, so which is equal to u plus half into 2 3 are 6, 6 minus 1, 5a. Okay, half into 5a, or which can be written as u plus 5a by 2, calling as suppose Now from equation 1 and 2, okay, so we will solve these two equations. Okay, now see here, subtract equation number 2 from equation 3. Okay, so S7, suppose we can say that S2, okay, here S1, so S2 is equal to, or we can say that S common. Okay, so we get S is equal to U plus 13a by 2 minus S is equal to U plus 5a by 2, so minus minus minus. Okay, so we get now see, with displacement also given, we did not substitute the displacement, that is 15, so here 15 also. Now here S is equal to 31. Okay, now subtract, that means 31 is equal to U plus 13a by 2 minus 50 is equal to U plus 5a by 2. Minus means minus minus minus, so we get 31 minus 15. 31 minus 15, 16. Okay, which is equal to plus U minus U, 0. 13a by 2 minus 5a by 2, base is same, that means as it is 13a minus 5a, so 8a. Okay, so 60 is equal to 4a, so a is equal to 4. Okay, a is equal to 4. So now substituting the value of a in equation number, suppose 2, so we get 50 is equal to U plus 5 into a divided by 2. So 2 1 the 2, 2 2 the 4, 5 2 the 10. That means U is equal to 50 minus 10, which is equal to 5. So U is 5 meter per second and acceleration is 4 meter per second. Okay. According to that equation, we will solve these numericals. Now see, next concept, that is relative motions. My diagram is not proper or drawing is not well, but for understanding the concept, I will do best try. Okay. Now see, here are two railway tracks. Okay. Now these tracks also know, suppose we know that this is the track A and this is the track B. Okay. Now on this track, both the tracks, two trains are travel or moving. Okay. Both the trains are traveling or moving in same direction. Okay. Both the trains are moving in the same direction with same speed. Okay. Now you are here or you are in train A. Okay. And then you see this train. Okay. Then you understand that both the trains are at rest. Okay. When you see this train, then the speed of both the trains are same, both are traveling in the same direction. Okay, and you are sitting here. When you see this train, then you looks like, that means this train relative velocity. Okay, now let's consider let VA be the velocity. VA, I will here relative velocity. Okay, now let VA be the relative velocity of, suppose, velocity of object A, and VB be the velocity of object B. Okay, now the relative velocity of object A with respect to object B. Okay, the relative velocity of object A with respect to object B. Okay, so it can be written as VAB, that means relative velocity of object A with respect to object B. So it can be calculated by the VA minus VB. Okay, so it is relative velocity of object A with respect to object B. Okay, similarly we can calculate the relative velocity of object B with respect to A. It can be calculated by VB minus VA. Okay, so this is the relative velocity.